When you introduce peptides into your system, you're not just triggering localized healing responses. You're engaging your entire immune architecture. And if you're not strategic about immune tolerance, you risk triggering the very inflammation and autoimmune dysregulation you're trying to avoid. Welcome back to Peptides and Performance. I'm your host, and today we're diving deep into one of the most overlooked aspects of peptide protocols, immune tolerance and how to maintain optimal immune balance while using healing peptides like BPC 157 and TB 500. Before we go further, I need to be clear. This content is educational and research-based. We're exploring what the scientific literature suggests about peptide mechanisms and immune function. This is not medical advice, and nothing here should be interpreted as a treatment or cure for any condition. If you're considering peptide use, especially if you have a history of autoimmune disease or immune dysregulation, consult with a qualified healthcare provider. Now, let's talk about what actually happens when peptides meet your immune system. Your immune system operates on a delicate balance. On one side, you have pro-inflammatory responses, your body's way of fighting threats and initiating healing. On the other side, you have regulatory mechanisms that keep inflammation from spiraling into chronic dysregulation. This balance is called immune homeostasis, and it's critical for long-term health. When you introduce peptides like BPC 157 or TB 500, research suggests they work by modulating growth factors, promoting angiogenesis, and supporting tissue repair. But here's what many people don't realize. These mechanisms can trigger immune signaling. Your body recognizes that healing is happening, and it responds. If your regulatory immune pathways aren't robust, you can end up with excessive inflammation, immune activation, or worse, a flare in underlying autoimmune conditions. Let's break down the mechanism. BPC 157, or body protection compound 157, is a synthetic peptide derived from a protective sequence found in gastric juice. Research in animal models suggests it may support nitric oxide production, promote blood vessel growth, and modulate inflammatory cytokines like TNF-alpha and IL. 6. TB 500, or thymosin beta-4, is a naturally occurring peptide that research indicates may support cell migration, reduce inflammatory markers, and promote tissue remodeling. Both of these peptides appear to work, in part, by signaling your immune system to shift from a pro-inflammatory state toward tissue repair. But, and this is critical, that shift only works smoothly if your regulatory immune pathways are functioning well. If you have compromised regulatory T-cell function, elevated baseline inflammatory markers, or a history of autoimmune reactivity, introducing these peptides without immune support can backfire. Now, what does the research actually tell us about immune tolerance during peptide use? The evidence is still emerging, but here's what we know. Studies on BPC 157 in animal models suggest it may reduce pro-inflammatory cytokines while supporting anti-inflammatory markers like IL-10. TB 500 research indicates similar patterns: reduction in TNF-alpha, support for IL-10 production, and modulation of immune cell migration. These are positive signals for immune balance. However, and you'll hear this theme throughout, most of this research is conducted in controlled animal models or in vitro systems. Human data is more limited. What we can say is that the mechanisms these peptides engage are real. They do interact with immune signaling, and therefore, immune tolerance management is a legitimate consideration. So how do you actually maintain immune tolerance during a peptide protocol? There are several evidence-informed approaches. First, baseline assessment. Before you start any peptide protocol, you should ideally have markers of immune function and inflammation. This might include high-sensitivity CRP, homocysteine, complete blood count with differential, and if possible, cytokine panels. You're looking for baseline inflammatory status and any signs of immune dysregulation. This gives you a reference point. Second, dose and frequency matter. Research suggests that lower, more frequent dosing of peptides may be better tolerated than higher, infrequent doses. Why? Because it allows your immune system to adapt gradually rather than being overwhelmed by a large acute stimulus. This is the principle of hormesis, small, repeated stressors that trigger adaptation without crossing into pathological territory. Third, support your regulatory immune pathways. This is where lifestyle and targeted supplementation come in. Adequate sleep is non-negotiable. During sleep, your body upregulates regulatory T cells and anti-inflammatory signaling. If you're running a peptide protocol on 6 hours of sleep, you're working against yourself. Aim for 7 to 9 hours consistently. Next, consider your microbiome. Research increasingly shows that gut dysbiosis correlates with immune dysregulation and autoimmune flares. A diverse, healthy microbiome produces short-chain fatty acids that support regulatory T-cell development. During a peptide protocol, maintaining microbiome health through adequate fiber, fermented foods, and potentially targeted probiotics may support immune tolerance. Stress management is another critical factor. Chronic stress elevates cortisol and suppresses regulatory immune function. If you're running a peptide protocol while under significant psychological stress, you're creating a situation where your immune system is primed for dysregulation. Meditation, breathwork, or other stress reduction practices aren't optional. They're part of the protocol. Now, let's talk about specific nutrients that research suggests may support immune tolerance. Vitamin D is foundational. Research shows that adequate vitamin D status correlates with stronger regulatory T-cell function and lower baseline inflammatory markers. Many people in northern climates, or those with limited sun exposure, are deficient. Optimizing vitamin D, typically to levels around 40 to 60 nmol, may support immune tolerance during peptide use. Omega-3 fatty acids, particularly EPA and DHA, have extensive research supporting their role in immune modulation. These fatty acids are incorporated into cell membranes and influence inflammatory signaling. Research suggests they may reduce pro-inflammatory cytokine production while supporting regulatory pathways. During a peptide protocol, adequate omega-3 intake may be protective. Polyphenols from sources like green tea, berries, and dark chocolate contain compounds that research suggests may support regulatory T-cell function and reduce inflammatory markers. These aren't magic bullets, but they're evidence-informed additions to an immune-supportive protocol. Here's something else critical. Monitor how you feel. This is where self-awareness becomes data. Are you experiencing joint pain, fatigue, or skin flares after starting peptides? These can be signs of immune activation that's crossed into dysregulation. Research-informed practitioners track subjective symptoms alongside objective markers. If you notice signs of immune flaring, that's a signal to adjust your protocol, potentially reducing dose, increasing spacing between injections, or adding immune-supportive interventions. Let's also address a common misconception. Some people think that because peptides are natural or derived from the body's own compounds, they're automatically safe for people with autoimmune conditions. That's not accurate. Any intervention that modulates immune function carries risk for people with dysregulated immune systems. The fact that BPC 157 and TB 500 appear to support healing doesn't mean they're universally safe. Individual variation is huge. This is why baseline assessment and ongoing monitoring matter so much. You need to know your starting point, track your response, and adjust accordingly. This isn't a set-it-and-forget-it protocol. It's an iterative process of observation and refinement. Finally, let's talk about cycling and breaks. Research on other hormonal and growth factor-based interventions suggests that cycling, periods of use followed by periods of rest, may help maintain immune tolerance and prevent adaptation or dysregulation. While specific cycling protocols for BPC 127 and TB 500 aren't well established in human research, the principle is sound. Giving your immune system regular breaks from immune-modulating interventions may support long-term tolerance and prevent flares. To summarize, peptides like BPC-87 and TB500 work by engaging immune signaling and promoting tissue repair. This is beneficial, but it requires that your regulatory immune pathways are robust. You support immune tolerance through baseline assessment, appropriate dosing, sleep, stress management, microbiome health, targeted nutrition, symptom monitoring, and strategic cycling. This isn't complicated, but it is intentional. The research is still evolving on human peptide use and immune tolerance. What we know from mechanistic studies and animal research is promising, but human data is limited. As this field develops, more evidence will emerge about optimal protocols for immune-sensitive individuals. For now, the approach is evidence-informed caution combined with careful self-monitoring. If you want a comprehensive guide to peptide protocols, immune considerations, and evidence-based strategies for optimizing your peptide use, we've created a free peptide guide that breaks down these concepts in detail. You can download it at performancepeptides.io. The guide covers mechanisms, practical considerations, and research summaries to help you make informed decisions about whether peptide use is right for you. Remember, this content is educational. It's not a substitute for personalized medical advice. If you have autoimmune disease, immune dysregulation, or any chronic health condition, work with a qualified healthcare provider before starting any peptide protocol. Your individual circumstances matter, and professional guidance is essential. Thanks for watching. If this content was valuable, subscribe for more research-backed deep dives into longevity, peptides, and performance optimization. See you in the next one.